A customer support bot works perfectly in testing. Then production traffic starts. One user asks, "Summarize my ticket as JavaScript object notation, JSON." The model returns valid JSON, plus one friendly sentence. "Hope that helps." Your parser crashes. Your retry code sends the error back to the model. The model apologizes, returns almost JSON, and the loop burns tokens for 3 minutes. Nothing was wrong with the application programming interface call. The missing piece was an instruction layer that said, "Always return only the required format, and never add commentary." The first beginner move is to put everything into one big user prompt: the task, the rules, examples, data, tone, and output format. That works for a one-shot demo. It breaks when the conversation gets long, when users add conflicting instructions, or when you reuse the same assistant for a second task. The model is reading a pile of text and trying to infer what matters now. If your durable rules are buried beside today's data, they compete with conversation noise. You have no clean place to say, "This is the assistant's job, these are the boundaries, and this is how every answer must be shaped." The core idea is simple. System equals who you are and your rules. User equals today's task. In a large language model, or LLM, chat call, messages usually have roles. The system message is the instruction layer you control before the user speaks. It is not magic, and it is not a security boundary by itself, but it is the right home for durable behavior. Put the assistant's role there. Put constraints there. Put output format there. Put escalation rules there. Then keep user messages focused on the current request and the data needed to complete that request. Here is the build pattern I use. First, write a function or constant called something boring, like write system prompt version 1. Start with identity. You are a support triage assistant. Then scope, what it does and does not do. Then constraints. Ask when required fields are missing. Do not invent tool results. Do not claim actions were completed unless a tool confirms them. Then output format, maybe plain text, maybe strict JSON. Then escalation, when risk is high, stop and ask for human review. Store that prompt in your repo. Give it a version. Review changes like code, because it is code that changes behavior. Let's make this concrete. You are building a ticket triage helper. The system prompt says, "You are a ticket triage assistant. Classify tickets into billing, bug, account, or other. Return only JSON with category, urgency, summary, and needs human. If the customer mentions legal threats, payment failure, security concern, or missing account access, set needs human to true. The user message contains only the ticket. I was charged twice and nobody answered my email." The model should not receive a fresh essay of rules every time. It receives stable rules in system, changing ticket text in user, and returns predictable structured output. Now the limits. A system prompt is more durable than a user message, but it is not a vault, and it is not a formal proof of behavior. Do not put secrets there. Do not put your entire knowledge base there. Do not put today's spreadsheet there. Data belongs in retrieval, files, databases, or the user message for that call. One-off instructions belong in the user message. Another trap. Tutorials often show a perfect prompt and skip testing. You need adversarial but safe tests, malformed inputs, long histories, and parser checks. The prompt is part of the product surface, not a motivational speech. This is one piece of the agent anatomy. The system prompt defines the assistant's role and standing rules. The harness, meaning your surrounding Python code, owns the actual control loop, tool permissions, retries, timeouts, and termination. Beginners often ask the prompt to do everything. That is fragile. The prompt can say, "Never call a refund tool without confirmation," but the code should still enforce who can call that tool and with what arguments. In later episodes, when we add structured outputs, tool calling, state, and memory, the system prompt remains the durable instruction layer that those pieces orbit around. Here is a safe 10-minute exercise. On your own machine, create 2 prompts for a mock assistant. Version A puts all rules in the user message. Version B puts durable rules in the system message and only the task in the user message. Use a harmless task like classifying personal notes into work, home, or health. Then extend the conversation with 5 extra messages, corrections, unrelated comments, and a request for a different format. Compare which version keeps the output stable. You do not need third-party systems or real customer data. You are testing instruction placement, not model cleverness. 3 beats to keep. First, the system prompt is where the assistant's identity, constraints, output rules, and escalation rules live. Second, the user message is for today's task and today's data. Mixing those layers is how long conversations become unreliable. Third, version your system prompts like code, because a one-line change can change production behavior. Tomorrow we keep building the foundation and connect this to context and token limits, where even good instructions can get squeezed. New Agent Foundations episode daily. The paid libraries at aislabs.ai go deeper with production patterns, evals, and reusable agent components.